Well, welcome to our next lesson on angles and angle measure. In this lesson, we're going to be doing a couple of different things. We are going to be converting between radian and degree modes, and we're also going to be identifying and labeling coterminal angles, and we'll be learning how to graph different kinds of angles as well. So first of all, let's start off by defining what an angle is, and I think we all know what an angle is. From geometry, you learned that angles are made up of two rays that are referred to as sides of the angle. They share a common endpoint, which is also called the vertex of the angle here. And when the angle is in standard position in the coordinate plane, usually we have that vertex at the origin. And there's one side that lies along the x-axis, that's called the initial side, and then the terminal side rotates and forms the angle. Okay, and the rotation of that terminal side creates the angle, what we call an angle of rotation, and we can rotate it either way. If we rotate it in a counterclockwise direction, we say that that is a positive angle. But if we rotate it in a clockwise direction, then we say that's a negative angle. So if you wanted to draw a positive angle, you start and go up into the first quadrant and on around, that's counterclockwise. But if you start and go from the fourth quadrant around, that's called a negative angle. The terminal side, we can have angles that are more than 360 degrees. Okay, that just means it rotates around more than one revolution. And each revolution around, you know probably already, is 360 degrees. So if you have an angle bigger than 360, that means you have more than one rotation. So in your homework, you may be asked to draw angles that are bigger than 360, and that's how you would show that. So if we were going to draw an angle in standard position, let's say I wanted you to draw a 240 degree angle. You're going to start on the x-axis, and since this one is positive, we're going to go into quadrant 1, through quadrant 2, and all the way into quadrant 3. And it's going to be 60 degrees more than 180, so a 240 degree angle. You would show that by showing the ends of your rays like this. You do need to include this angle of rotation in red here with an arrowhead so that I can see which direction you're going. That's an important piece of drawing your angle. So you're going to have the two rays and then show which direction you are rotating. A negative 30 degree angle would start on the x-axis, and it's going to have its terminal side in quadrant 4, and you're only going to go down 30 degrees. So here's two for you to try. Draw in a 450 degree angle and a negative 110 degree angle. So we finally get to talk about what is a radian. I know we've talked about that a little bit on your calculators, making sure that we were in degree mode and not in radian mode. Well, this is finally the lesson where we get to talk about what radians are and what we're going to use those for. And basically, a radian is just another unit of measure that we use to measure angles in. And it's defined using a unit circle. Now, a unit circle is just a circle with a radius of 1 unit. That's why it's called a unit circle. And a radian is the angle measure right here, this angle theta, when we have a unit circle with a radius of 1 and then also the arc length of 1 right here, then that angle that results in those conditions is called a 1 radian angle. So it's a little bit confusing, so everything's 1. So we have a radius of 1, an arc length of 1, which results in an angle measure of 1 radian. So how is this useful? Well, you can recall that circumference of a circle is 2 pi r, where r is the radius of the circle. And since we're dealing with a unit circle, our radius is 1. So our 2 pi radians, the circumference of a unit circle, is the same as 360 degrees. Well, that's going to help us to do conversions back and forth between degrees and radians. And 2 pi radians are 360 degrees. So if we wanted to convert from radians to degrees, what you're going to do is you're going to take the number of radians that you have. If we have 2 pi radians, I can go ahead and divide both sides of this equation by 2 pi, and then I will end up with 180 over pi, and that's the degree measure of 1 radian. If we want to go the other way, we're going to divide by 360 on both sides, and we're going to have pi radians over 180. Pi over 180 is 1 degree. So let's look at how that looks when we put that into practice. So converting between radians and degrees. So it says convert the degrees to radians and the radians to degrees. So here's what we're going to do. You always want to line up your units, just like I've shown you in the past with any unit conversion. We want the units that are the same diagonally from each other. So it's either pi over 180 or 180 over pi. That's our unit conversion. But we want it to line up diagonally so our degrees are diagonal from each other. And then we're just going to reduce that. 60 goes into 180 3 times, and that leaves us with pi over 3 radians. So a 60-degree angle is the same as pi over 3 radians. Okay? Over on letter B, we have negative 7 pi over 4. So we start with that angle measure, and we want to line up our radians so that they cancel. So we want the pi on the bottom and the 180 on the top. So that's our conversion factor. Okay, the pi's will cancel, and we'll get 7 times 180 divided by 4 with a minus sign in front of it. And if we simplify that, we end up with negative 315 degrees. So when you're going from radians to degrees, you multiply by 180 over pi. When you're going from degrees to radians, you multiply by pi over 180. And I've included a couple here for you as well to do to practice. Here is what's called the unit circle. This is something that you will be memorizing. Not only this information here, we're going to add some information as well. But for this, right now, don't panic on me. I'm going to show you a very simple way. Really, all you need to remember is the first quadrant here, which is going to be the 30, 45, and 60, what their radian measures are. We're going to talk a whole lot about this unit circle, and we'll talk more about that in the future. So just for now, I wanted to get this in your notes to get you a little bit familiar with it, and we're just going to leave it there for now. Coterminal angles. So if you graph a 45-degree angle and a positive 405-degree angle, one of the things that you'll notice, if you go around once and then another 45, they have the same terminal side. And we give those kinds of angles a special name. They're called coterminal angles because they share the same terminal side. So in general, if you are asked to find coterminal angles, you are going to add or subtract 360 degrees. Or multiples of 2 pi radians. Depending on if it's given to you in degrees, then you'll add or subtract 360. If it's given to you in radians, you're going to add or subtract 2 pi or 4 pi or something like that, multiples of 2 pi. So let's take a look at some examples. So it says find a positive and a negative angle that are coterminal with the given angle. So for 240, if I want one that's coterminal with 240, I can just add 360 to it, and that gives me 600 degrees. If I want to find a negative angle, I can subtract 360, and that gives me negative 120. So there's a positive and a negative angle that have the same terminal side. In radians, I have 9 pi over 4. So a positive angle, I can just add 2 pi to that. And 2 pi, we need to have this in terms of fourths, right? So that'd be 8 pi over 4. And 8 pi plus 9 pi is 17 pi over 4. So getting a common denominator here before we add that together. So it gives us 17 pi over 4. A negative angle here, this one's a little bit confusing. If I subtract 8 pi over 4, if I just subtracted 2 pi, I would end up with a positive pi over 4, and that's not a negative angle, so I need to multiply by 2 again, so that's why I have 4 pi. So again, if we use this as fourths, that's really 16 pi over 4. So we have 9 pi minus 16 pi over 4, which gives us a negative 7 pi over 4. That will do it for this video. We'll see you in class.